This session is about cylinders. Now that we have discussed about surface areas and volumes, let's now enter into understanding what is a cylinder. As we have seen this real life model, I see that this CD stand clearly has various different CDs lined out on the rod. Now if I take one CD out from this, it looks like a circle. So I see this CD stand to be a set of all circles built up so that it forms a three-dimensional shape. So let's understand a cylinder through the concept of the CDs. So a circle, as in this model, when I take and I put another circle or a 1 rupee coin or a CD, as we have seen in this model, one over the other, we see that the different types of CDs as built forms a sort of a shape which looks like this. And this kind of a shape as formed by these CDs is nothing but a cylinder. So in mathematics, the set of infinite circles built on each other to form a cylinder is how we understand through the mathematical means. Now let's try to make it more brief about a cylinder. As we have seen, the different sets of circles but provided if I take two different CDs, I see that the two CDs are equal in size. The two CDs do not have different sizes, but the two circles are assumed to be of the same size. The rule for constructing a perfect cylinder is that all the set of infinite circles must have same size. This is how we understand the important means of constructing a cylinder. So as we come through the model, I see that all the cylinders, all the circles which form the cylinder have the same size, and therefore it constructs a straight figure which is called a cylinder. Different set of circles of same size to be noted down form something like a three-dimensional object which is called a cylinder. So a cylinder built from different set of circles constructed on each other, of course of the same size. This session is about understanding what a right circular cylinder is. Now that we have understood the cylinder to be constructed from set of circles, let's now try to understand the most important part of cylinder, which is called right circular cylinder in mathematics. This session is about right circular cylinder. What is a right circular cylinder? What is the difference between a cylinder and the specific cylinder given by the name right circular cylinder? So let's see this in brief. So as I see right circular cylinder, I have three different things which I understand: the one which is right, the one which is circular, and the one which is, of course, a cylinder. Circular and cylinder. So we differentiate a right circular cylinder into three classifications. One is this, this, and this. Let's understand each of this to understand the whole concept of right circular cylinder. As we see, right in mathematics means the one which is at right angle or 90 degrees is how we understand a cylinder. A cylinder which is exactly straight as 90 degrees is called a right circular cylinder. And of course, the cylinder must be circular. It cannot have a different shape other than each of the circles being constructed to form a cylinder. And circular at every stage. Every stage and equal in size is how we understand circular. And of course, it must be the shape of a cylinder, as we have seen in the previous model of the shape of a cylinder. So this is how it looks. It must be cylindrical in shape, as this we see as a cylindrical shape. Therefore, a right circular cylinder is a three-dimensional solid which is in the cylindrical shape and which has circles which are equal in size at every stage. I take a CD here or any stage of, they are equal in size. So circular at every stage and equal in size. Right, that is, it must be exactly 90 degrees to the ground. If the cylinder is cross, then we say it is not a right circular cylinder. The angle between the ground and the height at which the CDs rise must be 90 degrees. Right angle or 90 degrees is how we see a perfect cylinder. Is how I have the base which must be exactly from the ground at 90 degrees. Cylinder which is right circular has three important classifications. Right circular cylinder. Now that we have identified the definition of a right circular cylinder, let's see some of the objects which are right circular and which are not right circular. For example, I take a cylinder which is crossed. It is crossed out here, and then this kind of a cylinder cannot be right circular because the angle between the ground and the height at which the cylinder rises is not 90 degrees. That is, if I take this to be a ground, then this angle is theta, and here this angle is not equal to 90 degrees. Is how mathematically we identify a right circular cylinder. The angle between the ground and the height at which the cylinder rises must be 90 for the cylinder to be right circular cylinder. Theta is not 90 degrees. Therefore, the given cylinder is not a right circular cylinder. Since theta is not 90 degrees, therefore the given cylinder is not a right circular cylinder. Is how we understand. Let's take one more example to understand the classification between right circular and a non-right circular cylinder. For example, I take a shape which looks like a cylinder, but actually this solid is formed by constructing a different object which is in the shape of this. So each of a shape which is not a circle is constructed. If the shape, something which is like this, is used to construct, just like an egg shape, so this is an egg shape which is constructed, then this cannot be a cylinder, right circular cylinder, because we demand for circular concept in right circular cylinder. So if this is egg shape, then this is not a right circular cylinder. Though it is 90 degrees from the ground, it cannot be right circular cylinder because it has to be a circles which are constructed to form a cylinder. The reason being, each of the constructed objects are egg-shaped. Is how we understand the right circular cylinder demanding for three different rules: this, this, and this. Now let's see one more solid object to understand right circular cylinder concept more stronger. Suppose I have a circular cylinder which bulges out here like this. This seems to look like a cylinder, but this is not right circular, though it is 90 degrees from the ground. And though I see this 90 degrees from the ground and I see this being a circle, still I say this is not right circular cylinder because each of the circles as constructed in the cylinder are not of same size. So here it is very important to note that this kind of a cylinder cannot be right circular cylinder. This is not a right circular cylinder, as each of the circles as constructed to form a cylinder are not of same size. This is the main reason why this cylinder does not become a right circular cylinder. This is not a right circular cylinder as each of the circles as constructed to form a cylinder are not of same size. They must be of same size. This is a perfect right circular cylinder because each of the CD of the same size is constructed to form a cylinder. Circle of same size makes a solid right circular cylinder.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.